Welcome, ladies and gentlemen, to a data structure and algorithm tutorial by Brainy Brackets. On the agenda, we will look at what is video notation, what is computational thinking, what is space and time complexity, and why does it all matter. So, what is video? Video notation is a type of priori analysis. Well, I'm not going to give you this jargon. I'm going to tell you a story. So, what is Bigo exactly? So we had internet. We had this internet. It's a real story in South Africa. We had this internet, and we had the bird, a bird. And the whole story was based about whether a bird could beat the internet. A bird could beat the internet. We had a lot of press coverage on the story. A lot of press coverage on the story. And there were a lot of people watching on the televisions. People watching on the television, people actually went to the venue to see whether a bird can beat the internet. Well, and what beat the internet? So it turned out the bird actually beat this internet. The bird won. The bird was a victor. The championship, there we go. The bird was our victor. So what does this all have to do with programming? As the story goes, we had the bird and the internet. And it goes back to when you first start programming, you think maybe what should I program with? What's a popular programming language or whatnot? Well, this is why data structures and algorithms are important. And I'm going to stress why now. Say we have binary at the bottom, what machines to execute. We have bytecode or assembly. We have assembly and assembly. And we have languages that are higher up, such as Java, C, C++, Java, Python, and JavaScript. So it turns out these characteristics doesn't only apply to programming language. So the reason why the bird one was fairly obvious, the internet was slow and crappy in South Africa, but there's more reasons to it. There's more than one reason. You could say the test wasn't fair. The test was not fair. Because a bird does get tired. And there's so many factors. Oh, a bird does get tired, a computer does not. And they have different characteristics that you can't just factor in. Characteristics that don't factor in. So the board different. The board completely different. So when the bird carried the USB stick, it was unfair, and everyone was shocked at this. Well, I don't know. I wasn't born yet, but it's all different because it goes back to today, where we have all these different languages and lower level languages like C, and higher level languages like Python are different in characteristics, in character. It's like you and me, you and me, or you and your friends, and it all goes back to having different characteristics. All programming languages are different, implemented differently, have their own advantages and different disadvantages. But one thing that we can take in consideration is something known as an algorithm. Now, an algorithm actually, excuse me, let's go to the story, let's talk about it. So, say you have, say you ran the same, say you ran, send the same email with Python, and because Python's abstract, Python, because Python, sorry, send an email, the Python mail, and this email. You see that Python falls short, and this is the same thing we're trying to get rid of in the programming world. We got C email and we got Python email. So, BGO notation is a writing system. BGO tells us to measure independently of programming language. it's a type of priorly analysis. The other one is posterior, where you're actually running measuring in the language. Posterior analysis. Don't worry about this for now. We don't worry about this for now. Just a term we can keep in mind for later. Don't keep in mind it's fine. So, priori analysis. So, what does big O exactly measure? What are we telling the computer? So, in the computer realm, we have RAM sticks. Say you have RAM, we have memory from the RAM, which is also known as space, and we have the time. You have a time. An algorithm takes to run. So what are we measuring here? We're measuring the space and time. Space and time. Space and time. We have to take in consideration these two things to determine how fast an algorithm is, how efficient. So Big O tells us how efficient our algorithm is. Given the space and the time. As the input grows. Okay, so we're gonna look at what is an algorithm now. So an algorithm is just a finite set of step-by-step instruction. We'll look at more of this in detail later. It's a finite set of step-by-step instructions. Finite set of step-by-step instructions. But keep it simple. Say say I asked you, make me a cup of tea. Or your friend asks you, make you a cup of tea. How would you go about that? So, how would you go about that? This is not introduction to computer thinking. Computational thinking, so just to know this. This is sorry, let me restart. This is computational thinking, but I want to focus on what I was talking about before. So, how would you go about making a cup of tea? There's no trickery in this question, and I want you to take your time and answer it. Write down your solution, or pause this video and write down your solution. I'll get the following items, depending on how you like the tea. Just how would you make a cup of tea? I'll get tea bags, sugar, cup, and milk. I'll boil hot water. Put the hot water in the cup. Add tea bags in the cup. Add the sugar in the cup, and finally add the milk. And voila, my tea bag. Sorry, my cup of tea is ready. And this is what is known as an algorithm. We had first stage, we declared we had some items, tea bag, sugar, cup, and milk. And these are like in computer programming, your base, what you need, your variables, your decorations, what you essentially require for your program as input. And you boil hot water, you pour hot water in a cup, you add tea bags, and you add sugar, and you finally add milk. That's how I make my perfect cup of tea. So what exactly is Big O? We have to get to the point now. Because we have our algorithm. making a cup of tea, or sending an email. Making a cup of tea, sending an email. Counting coins. What is our main objectives? What is BGO? BGO just tells us, given the upper bound just means given the worst scenario. Given the worst scenario, sorry. Or given the worst scenario, say you had given the worst scenario, not the best, the worst scenario, given so given the worst scenario, as in given the worst input. So given the worst scenario, given the maximum input size, like say given the worst scenario, given the worst inputs, like we said before, like we had an algorithm, like making a cup of tea, you will have okay, let's go back to sending an email. That's more so given enough input, I prefer to stick with the email. So given a large input, a large input, upper, what is the worst case? Given sorry, given the worst case scenario, also known as the upper bound, how does this then affect our output, our runtime, our space, and memory time? So if you had, again, say if you put, so we had the same email, we're sending it in Python and in C. BigO measures the worst case, like the worst thing that can happen, the worst scenario, like for example the upper bound, in the sense that the maximum time, that's the word I was looking for, sorry guys, the maximum time cost, memory it takes for our algorithm to run. Our algorithm to run independent of the programming language. So we're never going to be thinking about the programming language. So it's just like we're just gonna measure it like in pseudocode, because not even pseudocode, that's a bit confusing. We're gonna use, say you had a program and you rewrite it in something called pseudocode. You write it in pseudocode. Instead of counting instead of counting the runtime program of the program in the language or counting, which is known as runtime analysis. We're counting we are still counting number of operations, but we're still counting we're counting how it affects time and memory. Time and memory. Time. Now we're gonna speak about bigger or more there, but if you feel like you're interested, you can Google the best case scenario or big omega, and the average case scenario, big theta. These are also all types of priori analysis. And why priori analysis is important? Because we're measuring our algorithm. We're measuring pseudocode, or like, let's say pseudocode. We're measuring pseudocode which is fake code. Pseudocode just means fake code. By counting operations, Now, when we actually, thank you guys for watching. See you in the next tutorial because it's getting late. And as always, like, share, subscribe.